Later this year, a 3D printer will be heading to the space station. This was a partnership between a commercial company called Made in Space and NASA's Marshall Space Flight Center.
So we would like to have the camera move to the CM.
Bill Hubscher spoke with Mike Snyder of Made in Space and Nikki Werkheiser from Marshall to find out more about working with small businesses on projects like this and the opportunities in the future.
Made in Space, the goal of the company is to advance manufacturing to space, so that way we can change the logistics chain so it's easier to get there. And me, personally, I'm a colonization advocate. I realize that it's very important that we start expanding as a species, not just exploring, but staying there. And this is one technology that's very crucial to that happening, and it's going to benefit exploration and colonization, and the things being produced can help research on Earth.
Let's shift gears a little bit. Can you tell me a bit about your partnership with Marshall?
They're really crucial. We talk to them all the time, and there's great people here at Marshall that helped us along the way with anything we needed. Marshall has been crucial to this development process. After our phase one, we got actually during our phase one SBIR, we talked to them, and they were really interested. Actually, Ken Cooper, who is based here right now, flew a additive manufacturing device in the late 90s aboard the Vomit Comet. And so there was definite interest here already. And we talked to Ken early, before we even were the SBIR, to actually understand what he learned from his experience.
What are some of the tools that you expect to be made using this device?
I guess the better question in that one was what tools can't be made with the device. You could do pretty much anything with 3D printing. It's very, very unique technology capability, because you can create geometries that you wouldn't be able to machine traditionally. And that's really awesome, because the best things that are going to come out of this, I haven't thought of yet, because people are just opening the door to the new capabilities and understanding how it works. And it's going to be really cool in the future to see what people come up with. Currently with the technology demonstration, we're using ABS plastic. The future generation of printer that goes up next year will have a wide range of thermopolymers, and some of those are aerospace grade. This printer works like many additive manufacturing devices work on the ground. It deposits material layer upon layer and builds up a three-dimensional object. Think about a glue gun at home. You can just press the button and it squirts out. If you kept going, you can create objects in 3 dimensions that way. And that's pretty much how the printer works. The next step for us is, this is a technology demonstration to see if it works properly and reduce risk for our commercial platform that goes up next year. And that will be able to let anyone build what they want on station, which is really exciting and really quick. You can do it really quickly. Instead of waiting 6 months to a year for your rocket to go up, you just press a button and your part's there. The future of additive manufacturing in space, in my opinion, is very bright. We're just now getting off the ground with this technology and utilizing it. So pretty soon in the future, we're going to be able to build more useful things up there that are bigger and more complex, with more components, more materials. And sooner rather than later, we're going to be able to build spaceships up there. That might seem far-fetched right now, but if you think about how far the technology has gone in the last 10 years and just expand that, it's not out of the realm of possibilities, which is really exciting, because we need to get off this planet and explore and colonize. And when we do that, we're going to have so many benefits to the terrestrial environment that they're going to outweigh the amount of effort it's going to take to get these type of technologies up there and working in space.
The 3D printer is the very first step toward realizing an in-space manufacturing suite of capabilities. The printer is key and crucial to that. We'll be doing multiple materials in the future. We're starting with this ABS plastic, which is what you see in like Legos, for example. But from there, we'll move to other thermoplastics, stronger thermoplastics that can do different types of parts. In addition to that, we'll eventually have a metals capability. Metals are a little trickier. We're starting with the plastics because a lot of what you see on the ground for the metals will be a powder based. You have a real fine powder that you use. And we haven't figured out how to manipulate that in microgravity. The powders are very hard to control. So there are other processes that we're examining. But in addition to that, we just awarded 2 other Phase 1 SBIRs on a whole new topic related to in-space manufacturing. You can imagine in space, flying up the feedstock is still a supply chain that we would like to be able to get rid of. So one thing we're doing is we have a Phase 1 SBIR we just awarded to Made in Space and Tethers Unlimited to look at how you would take the small plastic part that we print and you recycle it back into the raw feedstock. So that is a very exciting day. We would be, sustainable in that case, and then do the testing necessary. How many times can you reuse and redo that? One day what we'd like to be able to do is turn things like our old food wrappers and water bottles on station, the trash, into feedstock and print from those. So we'll be cranking that phase 1 SBR process up. It's another example of how the SBR has been the perfect mechanism for this type of capability development. And then you even think bigger. You start thinking about things external to space station, things like building trusses or large structures, antenna. Many of the things that we build on the ground that we fly in space, large structures like antenna or Hubble Space Telescope, when you're designing those, you really have to kind of imagine what that environment will be in space and try to design for that. But if you could actually build these things in space, in the environment you're operating in, you can build them to just that environment. So it's kind of a mentality shift and a whole new way of thinking. We have things like printable electronics that are in work on the ground that we would like to be able to translate into space, as well as things like in-space repair. Something like, I know a lot of people have seen the movie Gravity, but MMOD, the micrometeorite damage, is something we do worry about. It could happen. So this would be a way to actually build a patch in space if something like that were to occur.